Hey everyone, in this video we'll see that how we can delete an element from the end of the single linked list. Let's start. So in this video we'll talk about that how we can delete an element from the end of a single linked list. So at first what we have to do, we will store the last node in a separate pointer and we have to use the function that is called free. So this free function, we get this free function from the stdlib.h library. So using that we can deallocate a memory. So we have to use the free function for deallocating any memory from a single linked list. So we have to store the node into a separate pointer, then we'll deallocate the node. But there are some steps that we have to follow. Then we will set the next address null to the n-1 node. So what do you mean by n-1 node? So let's say that we have 5 nodes. So let me draw a diagram. Let's say that we have 3 nodes. So these are the 3 nodes that we have. You just pause this video and write in the chat section that what this portion contains. So the next address of the first node will contain the address of this node. This node contains the address of this node, but what this portion contains? It contains null. So it contains, so when we'll delete or deallocate this memory, then what we have to do? We have to set this portion as null. So this portion should be null, because if we deallocate this memory and if we are trying to access this memory, so because this memory address is stored over there, right, then we won't find that, right? That's why we can face a segmentation issue, or then it will be a dangling pointer. So for that what we have to do, we have to set null over here. So at first we have to store this address into some pointer, then we'll free that, then we'll set this portion as null, then we can traverse the list as well. So these are the steps that we have to follow. Now let me delete all these things. Yeah, so this is the data, this is the next address. Now we'll see that how we can do that. You can see that this is the list that we have, this is the output list. So at first what we have done, we have separated this node. Let's say that let me rename all these things. The address of this node is FFF0, FFF0. The address of this node is FFF2. The address of this node is FFF4. It will be F, yeah. So then what we'll do, we'll take a temp pointer. So let's just write temp equals to, then within temp we'll assign FFF4. So you can see that we have a temp pointer, we have taken this node. Then what we'll do, we'll implement free over here, then we'll deallocate this node and we'll set null over here. Then we can traverse the list as well. So this is how we can delete an element from the end of a single linked list. Now so we'll take a reference pointer, then reference pointer will traverse the list, and at last we'll free this pointer. So what I have told earlier, that we won't move the head pointer, we only move the reference pointer. We'll move the head pointer for deleting anything from the beginning, but we won't move the head pointer for doing other stuff. We will only move the head pointer for deleting an element from the beginning or inserting an element at the beginning of a list. So let's focus at the algorithm. Then what we have to do, at first we have a node and there is a function for delete at end. Then at first what we'll do, if our head contains only one value, if our head next equals to null, if our head next equals to null, let's say that we have only one value, this is the head node and this is the thing we have, let's say that 10 xxx, here we have xxx. So if our head next equals to null, if we have only one value, then what we'll do for this case, we'll just put del over here, del equals to head, then del will also contain triple x, then we will put head equals to null here. So then our head will be null. It will be null, and del will be pointing to this node. I think this portion is clear. Now for another case, what we'll do, there is a else condition. This else condition is for n number of nodes. If we have one node, then we'll go for this thing. If we have more than one node, then we'll go for the else condition, and at last we'll deallocate the memory. So I'll talk about the deallocation later. So for the single node, we have followed this thing, and for the multiple nodes, what we'll do, this portion is for the multiple node. We will traverse t next. We'll traverse two steps. So we have to check that we have to deallocate these things, right? Let's say that t is here. Then we'll check that t next. So t is pointing to this node. Let's say that this is the t. What is the t next? That is fff2. T next is not null. What we can do, we'll take a reference pointer, that is t. Now what t does, t is pointing to the same node, that is fff0. This is fff0. Now we will check that what is the t next. T next is this thing, that is fff2. What is the t next? T next is this, and next is this. So I haven't taken any previous pointer. There is a concept of previous pointer, but for the better code I have used only one pointer. You can use two pointer as well, but I have used one pointer. So there can be a wastage of memory. So I have taken one pointer. T next equals to null. Now what is the t next? Let me remove all these things. T next is this node. T next is this node. This is null, right? T next is fff2. What is the next of fff2? That is null. If a t next not equals to null, then only we'll move the t pointer, else we won't move the t pointer. If it's not null, then we will terminate the loop, and we'll put the t next over here. T next means we will put t next. So we have to delete this thing, right? So we'll put t next means this node into del. Del will contain fff2. We'll deallocate that, and we'll put t next equals to null. So this thing will be null. It will be null. So I think this portion is clear. Now at last we'll feed a del. I'll explain this thing again. So let me remove all these things. I'll explain this thing again. So let me take four nodes. This is node A, this is node B, this is node C, this is node D. Now let me take that this is f1, f2, f3, f4. Now what are head contains? Head will contain f1, and t will be pointing to the same node. T will be pointing to the same node. So head is pointing here. So what f1 contains? It contains f2. So what f2 contains? It contains f3. What f3 contains? It contains f4. This is the address of this node. And what f4 contains? It contains null. Now we have to deallocate this memory, right? We have to deallocate this memory. So for that, what we'll do, we'll take t as head. So we have taken t as head. So head next is not equals to null. So this portion won't run. Then we'll come here. T next. So what is the t next? So we'll see that what is the value of t next and t next. The value of t next. So my handwriting is very bad, so I'm trying to write next. So what is the t next? Now at first, what is the value of t? That is head. So the value of t next is f2. The value of t next is f3. So f3 is not equals to null. So this portion will satisfy. Then we'll move the t to t next. Now what will be the value of t? The value of t will be f2. Now what will be the t next? Let me draw a line. The value of t next will be f3. Now what will be the value of t next? It will be f4. So t next not equals to null. It means this portion will also be executed because t next equals to f4. Then we'll move the t pointer here. Then what will be the value of t next? It will be f3. Then what will be the value of t? It will be f3. Now what will be the value of t next? The value of t next is f4. And what will be the value of t next? It will be sorry, it will be null. T is pointing here now, F3. What is the value of T next? That is F4. Now what is the value of T next? That is null. So this portion will not be executed. This loop will be terminated. Then we will put del equals to T next. So what is the value of T next? That is F4. We'll write del equals to T next. Oh, T next is written over there. So we'll assign del equals to F4. Then we'll set T next equals to null. So what do we mean by T next? This is F4. So we'll put null over here, null. So this thing will be null. It will be null. So this link will be discarded. Then at last we will delete the memory. So I think this portion is clear. I have repeated this process more than 2 to 3 times. So I think if you have any query, just write in the chat section. Now we'll go for the hands-on. So you can see the existing code over here. This is the insert function, this is the traverse function, and this is the delete at end. So at first we have checked that how many values we have. If we have one value, we won't check next. We'll only check the next pointer. And if we have more than one value, then we'll go to this portion, we'll check T next. If you have any doubt, just dry run this on your copy. So if you go through that once, then your every doubt will be clear. Or you just see this video more than 1 or 2 times, then your every doubt will be clear. So I think this portion is clear. I have explained this previously. We have inserted 3 values. We are traversing the list. We are deleting the value from the last. We have deleted the third value. We have deleted a second value. We have deleted the first value. So in this traversal, a list will be empty. So in this traversal, we'll get how many values we'll get? We'll get 2 values. In this traversal, we'll get 1 values. And in this traversal, we'll get 0 values. That is null. The head pointer will be null. So let me compile this code. You will see that what output we are getting. At first we'll put 100, then we'll put 200, then we'll put 300. So as you can see that we have got the output. At first we have inserted 3 data. In this line we are traversing this block. You can see that data present in the list, that is 100, 200, 300. In the 74th line we are deleting the value. You can see that last block deleted successfully. Then we are traversing here, data present in the list, that is 100, 200. Then we have deleted the last block. You can see only one data is present, that is 100. Then we are again traversing. You can see that one data is present. Then we are deleting the one and only block, that is last block is deleted from the list. We have deleted the last block. Then you can see that we have traversed the list and data present in the list is 0. So this is how we can delete the data from a list. So if you are trying to delete any data from a list, we have to follow these steps. If you have any doubt, just write in the comment section. See you in the next video.